posture management methods, we're going to be looking at some new syntax that was added to the compliance engine late in second quarter 2021. And this new capability will enable users to construct GSL queries. Again, the GSL query will always target a specific cloud resource type. Will enable you to construct queries that leverage data points that are stored within the CloudGuard service, but are stored in someplace other than the entity model you're actually evaluating. So this should be represent a major step forward, a capability that should extend the range of use cases for GSL and the posture management engine very significantly. We're very excited about this. Before I get started, here's a quick outline of the topic we'll be covering. We'll start with some caveats that are important, especially for any viewers who have not already had extensive experience with the posture management engine. Then I'm going to provide a little bit of context about exactly how this new capability extends the functionality of the posture management engine. And then I'm going to step through a series of illustrations that give a more hands-on feeling for where and how you can leverage these new capabilities. And finally, I'm talking about when and where and how you might make the best use of these new capabilities, and actually discuss some scenarios when it would be less appropriate. All right, so to begin, first caveats. The posture management engine, it was designed and is designed to be very user-friendly. We have a point-and-click sort of tooltip guided query builder interface, which is very easy to use, even with very limited exposure to public cloud environments or to the CloudGuard service. And our governance specification language, or GSL for short, is designed to make it easy to generate executable posture management assessments, which have a form that's basically near plain English. Very easy for an English speaker to read the rule and immediately get an intuitive sense of what it is intended to accomplish. So with that said, the information I'll be covering today would represent some of the most advanced and complex kinds of queries that are possible to create with the posture management engine. So the contents of this video do not in any way represent the average level of expertise or complexity for most posture management functions. It's important to understand, again, for users who haven't had lots of prior experience. In fact, if you haven't had extensive prior experience with GSL, you may find it much more useful to stop here and review and internalize some of our training content that would be more introductory or intermediate level before proceeding. Okay, so first, if the new functionality extends scope of use cases for posture management assessment, let's first establish exactly the scope of capabilities that we currently support before we've developed this new getResource functionality. Right. So as most users will know, our posture management engine is built around a series of entity models, of cloud resource specific entity models. Probably approximately 200 of them now across all the platforms, each of which will encompass between several hundred and a few thousand individual data points. As data points, you usually hear me refer to as attributes. Others you may hear refer to them as properties. Whenever you select a particular resource type for evaluation in the GSL Builder interface, note here on the right-hand side, you're going to get a tree representation of the entire entity model for that resource. And I think at last count, this is the entity model for EC2, encompasses somewhere between 3,000 and 4,000 individual data points. So where does that data come from? What does it represent? A substantial share of it you could describe as collected data. That means these are data points that represent cloud resource configuration states that we are collecting directly from the public cloud platform via the APIs that customers granted us permission to access. And we're just storing the raw unmodified values directly in the entity models. So that's a fairly substantial share of them. A larger share of the data points, I believe, you could would be better described as enriched data. So these are also config state information that stored in the form of metadata that we're collecting from the public cloud API. However, in this case, we're talking about data points that are actually collected from APIs that target cloud resources other than the one you're evaluating. So here again, this is a little snapshot of part of the AWS EC2 instance entity model. And you'll see that in addition to raw data points we're taking directly from the data collected from that EC2 instance API, we're actually enriching the entity model with data points we've collected from the AWS machine image or AMI API. So there's lots of machine image details here. We are using calls to identifying the network interfaces associated with the instance to map this particular EC2 instance to subnets that it's attached to, and also to security groups that it's attached to. And then the subnets will be mapped onto route tables, and then there'll be further enrichment of the route tables with route information. So enriched data probably is the single largest category of attribute types you'll find in any model. And again, this the incorporation of this enriched data into each entity model is one of the key methods that we've used to make it easy for CloudGuard users to evaluate individual cloud resource types in a holistic manner, basically taking into account a very broad view of the security context that's relevant to each cloud resource. So that covers those two. Another category of attribute types that you'll find in many entity models I would call is derived. So these are actually synthetic data points that have no correlate anywhere in the public cloud metadata. These are data points that we are effectively synthesizing or deriving. They're the process of analytical processes or calculations that are conducted in the CloudGuard backend. So the canonical example for this is public. This is Boolean values, can be true or false at the EC2 instance level, and the Boolean value will be true if an EC2 instance is currently associated with any NIC that is currently associated with any routable, which is to say non-RFC 1918 IP address. So that set of data joins is summarized down to a single Boolean value at the EC2 instance level because that's such a important data point, is high salience in terms of security context, because that represents the key sort of host level prerequisite that must be in place in order for a workload to be able to communicate with anything outside of its private context, which would be a VPC in AWS under normal circumstances. So many of the entity models will have one or more derived data points like that. And finally, a few will also have data points that you could describe as interpolated. These do not represent configuration state information, but rather represent the results of some kind of evaluation or assessment process that is being executed outside of the CloudGuard service itself. Scanners here, this is actually something that would be generated. And again, these are optional values in every case. This is would be generated by the AWS config rules services. So if you're using those and you want to make those available to the CloudGuard service, you could have those results are addressable here. They'd be stored under the scanners attribute array. So just give it just a quick illustration. Here is live, the EC2 instance. This is, again, this is just a representation of the entity model for EC2s. This will be populating for each EC2 instance that is hosted in a CloudGuard protected AWS environment. I'll use a simple trick to get the compliance engine to enumerate all the workloads of the type that are targeted here. And now when you look at the results, we can look at the preview entity, and this is now the same tree model we're looking at over here, only in this case, we're looking at it complete with the actual current config values for the several thousand values that could be stored potentially for this particular EC2 instance. All right, so now how are we leveraging all this security context information in practice in the CloudGuard posture management engine, and how have those practices evolved over time? Here we're looking at a very simple network or design diagram for an AWS VPC. As you might have seen it, this would be typical of something you might have looked at several years ago, where we're really only focusing on presence of compute workloads, associated security groups, and looking at whether or not, the possibility that those workloads it may or may not be reachable from the internet based on the presence of that host level prerequisite and or the contents of any security groups associated with it. So here is a typical GSL rule which you might have would have been common from the time that the posture management engine, formerly known as the compliance engine, was introduced about 4.5 years ago. So here we're evaluating or attempting to evaluate the potential risk to compute workloads, EC2 instances, potential risk of over permissive ingress from from outside of that private scope, the VPC. And however, in the early days, we would evaluate that risk based only on two elements of security context. And again, there would be actually just one. Technically, we would say any EC2 instance that is currently associated with a routable public IP at the host level is potentially at risk for over-permissive ingress. So here we're looking for a security group inbound rules, which might be indicative of potential for external endpoints to reach that workload on a high privilege port, in this case TCP22 SSH. So this represents a kind of a naive or incomplete representation of the conditions that would be necessary for actual over-permissive inbound ingress risks to exist. Happily, our use of the extensive data that we're collecting has matured considerably since those days. And here we're now looking at something that would be more representative of our current generation of curated CloudGuard curated GSL rule sets, such as the one here, which is targeted towards default VPC design components in the AWS environment. And so now we're going to be limiting the scope of evaluation for potentially over-permissive ingress just to the subset of resources that not only possess that host level prerequisite, but also are hosted in a subnet which doesn't have any subnet level guardrails that would preempt any potential ingress that might be considered over-permissive from the outside world. So, and we are limiting that scope of evaluation by checking the workload's NIC and its association with any subnets, in association with the host subnet with any route tables that would include a route to an internet gateway. And again, that would be a necessary precondition in order for any internet gateways or VPC traversing structures that exist to actually have relevance to workloads hosted in that subnet. So here we're actually we're narrowing the scope of workloads that we're evaluating, and as a result, we're reducing the potential for generating false positives very, very substantially. And again, this is a much more robust application of the capabilities of the compliance engine. Right? We're using much more of the security context information that we make available to customers in order to generate results with much higher fidelity that are going to be much more operationally useful. Now, so this brings us to the context of the talk for today. What happens if the relevant security context in your own enterprise environment encompasses other data points that you would not find necessarily in the entity models of the resources that you want to evaluate? So, for example, if you are concerned about the possibility that an EC2 instance might provide, might contribute to risks of exposure to sensitive data stores, for example, S3 buckets, by way of some non-gateway or at least non-VPC gateway like VPC traversal structure. For example, maybe you're concerned about private endpoints that would allow easy access to S3 buckets. Then, if you were to look back at the EC2 instance model, you're not going to find anything about private endpoints. So there's no way to construct a simple, straightforward way to test for that, just based on the EC2 instance entity model alone. Happily, it is possible now, because we do store information about VPC endpoints elsewhere in our data stores. And there's actually a separate entity model that captures that kind of information. So we are collecting those data points that you might need to evaluate risks that a EC2 instance could either become a single hop source of unwanted exposure to stored S3 stored resources, or even become like a pivot point that would allow a path to be assembled by a malicious actor from an external context into your S3 stored resources. So now the question becomes, how do you get access to this kind of information when what you want to evaluate is the EC2 instance entity model? And again, if you can determine that the information that you actually want to evaluate is present somewhere, it's stored in some entity model that is currently supported by CloudGuard. That's the first prerequisite that you need to determine. You know, that you may be able to leverage this new methodology. So we see here that VPC endpoints, of course, they're the primary identifier in the VPC endpoint entity model. And I think these two labels need to be switched. Yes, they do. And in the EC2 instance entity model, in cases where there may be some exposure, you would find that VPC endpoint reference as part of the data we're collecting. Again, this being enriched into the EC2 instance entity model by way of the NIC and its relationship to the subnet, and its relationship to a route table, and its relationship of the route table to route, where the route would have a gateway ID that begins with a VPC endpoint prefix. So now we know that the potential for leveraging this capability exists. There's another question that you want to ask yourself before you leverage this methodology, and that is it necessary? Would it be efficient to actually evaluate this kind of risk from the EC2 instance model, entity model? Would it be simpler to actually create an evaluation for using the VPC endpoint entity and just test for that separately? In some circumstances, that would be the case. In that case, you would find that to be much easier than to try to assemble a compound kind of query like the one we're going to be building. So you should always consider that as an alternative before taking this more complex path. But if you determine that that is not feasible or would not produce results that would be useful to you, then now the question becomes, how do you actually leverage this new resource? So, and this new capability is basically the key building blocks are two new special purpose functions that you can leverage in GSL syntax. And one would be getResources. And this is where you identify the source of the data that you would like to access to sort of import into the context of the assessment that you're composing. And then get values where you're specifying exactly the particular data points that you want to pull in and you want to match up with the resource you're testing. So the structure of getResources is going to be, you're going to have use straight single quotes. Start with the name of the external entity model. In this case would be VPC endpoint, and this is exactly as that entity model is named here. And then you're going to have a generic kind of shum. You're just going to add the string capital I, lowercase d in the AWS environment here just to help join the data. And then the final term you're going to want to include in this getResources function is going to be any relevance conditions to limit the subset of resources of this type that you want to be allowed as potential match candidates, right? So if it makes sense in the context of your own query to test, to consider every resource of this type, the relevance condition would be unnecessary. You can just put ID. And then the value would be ID here as well. Now, there may be some cases here. Here is a sample kind of relevance condition that I have added in this particular context. And we're going to say we're only going to want to worry about this rule in cases where the VPC endpoint does not, the VPC endpoint does not have any policy level controls that are applied at the VPC endpoint level that would preclude the kind of permissive ingress or potential for unwanted exposure that we're concerned about. Again, this harkens back to my a comment before about trying to always choose the most efficient way to implement any control that you're trying to construct with the posture management engine. If all of your VPC endpoints they are all associated with very restrictive IAM policies that only allow access under very limited conditions, then perhaps this is not, there's no need to actually evaluate. There's no secondary risk like this that you need to consider. So this is just basically saying we're only going to evaluate EC2 instances that are hosted in a context where they have exposure to VPC endpoints that are not protected by some kind of restrictive IAM policy. And then we're just going to get back the resource identifiers that for the endpoints that basically would be risky and would in fact constitute a source of this kind of pivot kind of access risk. So so we'll look at this in practice. Here we have, this is what the final query would look like. EC2 instance, again, where this first portion here is just all the same details that you would look at in isolation. So you're looking for instance that has the kind of both host level, subnet level, route table level, and a gateway level that satisfies all of those conditions that would allow for potentially over permissive ingress, or you would look at also EC2 instances that would have a similar set of conditions that would allow them to easily access a VPC private endpoint. Again, it's not subject to any IAM policy restrictions. And in this case, you'd be leaving out the is public because that's of course one of the defining features of a private endpoint is that this makes it unnecessary for workloads that try to connect to it to have this, to satisfy this host level prerequisite, to have a public IP address. So if you were to execute this rule, complete with the additional syntax here, you would actually find that both of these workloads now would be considered non-compliant. This one because it has access both to, it's exposed to over permissive ingress per this definition through the internet gateway. And it also has access to a sort of unfettered the access is unrestricted by VPC endpoint policies to any resources that are stored as S3 buckets in that region. And this resource, this EC2 would fail because while it's not exposed directly to ingress from the internet, it's in the same subnet where others are. And it also has pretty much unfettered access to contents of S3 buckets in this region. So this is the advantage. This is an illustration of the advantage of leveraging this new getResource syntax. Now, very briefly, here's a couple more illustrative examples, and we're going to make this slide deck available to users who are interested, along with copy-paste ready versions of these rules. You can use some more illustrations of challenging kinds of posture management assessment requirements that could not be satisfied in the past, but which can now be satisfied thanks to these new operators. So here we have a case where you would like to assure that all S3 buckets have certain tag key value pairs, and that each bucket is also encrypted with SSE, and SSE encryption is encrypted with a KMS customer managed key that where the key actually possesses the same tag key value pairs. So there's a way of kind of a counting mechanism for assuring sort of parallel accountability of S3 buckets and encryption resources. And here are a couple of Azure examples. One that helps to assure that all Azure application gateways are protected by a WAF, and in this case could be a WAF that's actually implemented at the application gateway level, or could be a WAF that's implemented as a regional construct, and that the WAF protections that are present, regardless of their of the locus or scope of the WAF itself, will be configured to enforce OWASP version 3 or higher top 10 rules. And there's a similar illustration of a control that applies to Azure Kubernetes clusters to assure that they are protected by a virtual appliance, basically a firewall, either at the individual firewall level or at the regional firewall level. So just one final word, a couple of quick notes about troubleshooting. So again, all those new capability enables users to effectively import data points from a separate entity model and to leverage those external data points to construct GSL queries and to basically get valid answers back. The actual rule builder and all of the mechanisms that we currently support to represent assessment results, whether in the GUI or in some kind of notification output. These are all still single entity model centric, which means you're not going to see any data points in those outputs that are actually from that external data source. So that makes it especially challenging to troubleshoot and validate queries of this type. It's possible, but it's definitely not the sort of work that you would want to take on, again, if there's a simpler way to implement controls that don't require importing external data. So, and again, along the same lines, when you are attempting to construct or validate or troubleshoot a GSL query that leverages this new getResource syntax, the best and easiest and most transparent way to troubleshoot and to validate that you're actually getting the results you expect is to test your query incrementally, starting with the simplest possible implementation of the query, or the core of the query that you would ultimately want to implement in your environment. So consider, again, the query that we're evaluating is the kind of a primary example here. We are trying to map instances to environments where there's exposure to a VPC endpoint, in particular where a VPC endpoint is not protected by that endpoint level IAM policies. But the simplest query that you could construct that leverages, that includes both sides of the data join, that would include the data points that would reference VPC endpoint in ultimately the instance level entity model, as well as in the external data point. So the The simplest representation of that would involve, the one that would involve the shortest chain of associations would be to look at route table. Now, happily for us, route table is actually an entity model of its own. So you can construct a query that starts with route table. Route table should not have routes contain gateway ID. And then here's where you do the mapping from data points that are available in the route table entity to data points that are available in the VPC endpoint entity model. So once you've constructed, you've evaluated and confirmed, and again, this is a simple, should not have this basically, every route table that has a route that has a external endpoint that takes the form of VPCE-something should fail this test. So once you have a query that works like that, then you can progressively, again, once you, on the left side, on the relevance condition side, it's very easy to go from route table to instance should have nix contain subnet.route table. And also, once you are just using and here's an example of what I mentioned before. The simplest way to represent the subset of external data sources that you want to consider is to just consider them all. It's easy to replace ID, which would be the simplest representation, with the relevance conditions you care about. And again, in our actual example, we said we only care about those VPC endpoints that aren't protected by restrictive IAM policies. So we're looking, in this case, for endpoints, VPC endpoints that have a kind of default allow any IAM policy. So keep those tips in mind. They'll definitely make validation and troubleshooting of GSL rules that leverage the new getResources syntax much easier. So thanks very much for your attention. I hope you find this information useful. And as always, if you have any questions or comments, please reach out to your customer service representative or contact me directly at lvast@checkpoint.com. Thank you very much.